Welcome to page 3 on scale drawings. If you do not have a printed packet, which unfortunately we were not able to print packets for you, you can go to the PDF file labeled page 3 in your Google Classroom, and you can print a copy on your home printer. However, if you do not have a printer at home, you can use a blank sheet of paper or use paper inside a spiral notebook to copy down the notes and practice the problems as we go through them. For this first problem, example number 1, we are going to convert model dimensions or dimensions given on paper to actual dimensions in the real world. Let's take a look. We have been given a rectangle on paper that is 7 centimeters by 10 centimeters long. Please draw a rectangle that is 10 centimeters long by 7 centimeters wide. Pause the video if you need a bit of time. Now, as with any scale drawing, we are always given a scale. In this particular case, our scale states for every 2 centimeters on paper or in the drawing, it represents 15 feet in the real world. So you will always get, with any kind of proportional drawing, a scale. Whether that drawing is a map or a blueprint, whatever it may be, you're going to get a scale. The first dimension represents the blueprint or the map, or in this case, the model. The second dimension represents the actual or the real world dimension. So anytime we're given a scale, we're going to find a rate for that scale. We are simply going to put y over x, or in this case, 15 feet divided by 2 centimeters. We need to get a rate for this particular conversion. And in this case, punch into your phone or your calculator 15 divided by 2. That gives us a conversion rate of 7.5. When we set up our table, we're going to either multiply dimensions by 7.5 or divide by 7.5, depending on what we're doing. We're going to be using the table technique as we make our conversions. So let's begin. Create a quick T-table off to the side. X is going to be our centimeter measurements, or the dimensions we're given on paper. Y is going to be the actual measurements in the real world. We know for every 2 centimeters on paper, it's equivalent to 15 feet in the real world. Please copy down these notes. If you need to pause the video, please do so. Begin when you're ready. We know as we move from left to right, we're going to multiply by the conversion rate 7.5. But if we go backwards from right to left, we will divide by 7.5. In this case, we are going to convert 10 centimeters and 7 centimeters on the table. We know we're going to need to take 10 centimeters and we're going to put that under the centimeters column, and we're going to convert that dimension to feet. We need to multiply by 7.5 to convert 10 centimeters into the actual dimension that we're looking for. And the same is true for 7 centimeters. We're going to take 7 times 7.5 and convert that paper dimension into an actual dimension in feet. Pause your video and multiply each of those by 7.5. You should have gotten a length of 75 feet in the real world and a width of 52.5. Now that we've converted to feet, we're going to calculate the perimeter of the actual rectangle, and we're going to calculate the area of the actual rectangle. So we know that 10 centimeters is really 75 feet in the real world, and 7 centimeters is really 52.5 feet in the real world. Now, let's perform some quick calculations. Let's start with a perimeter walk. Please put this down on your paper and take notes. We know if we're taking a perimeter walk and we start right here, we're going to add 75 plus 52.5 plus 75 plus 52.5. 75 plus 52.5 plus 75 feet plus 52.5 feet. Take a moment, add up those 4 dimensions, and find out the actual perimeter. For area, you're going to use the actual dimensions and plug them into the formula area equals base times height. In this case, the base length is 75 feet, and you need to multiply it by 52.5 feet. Take a moment and calculate the area. And remember, area is measured in feet squared or square feet. Pause the video and calculate both perimeter and area. When you're ready, turn the video back on and check your answers. Compare your answers to the correct answers. Now let's move on to example 2, where we will take some actual dimensions and work backwards to model dimensions. We will be using the table technique again and calculating the model dimensions. Remember, use blank paper to take notes to complete the problems we are completing. If you do not have a home printer, you will not be able to print a copy of this page. Let's take a look at example number 2. In example number 2, we are given the actual dimensions of a rectangle. The length is 50 feet and the width is 25 feet. If we look at the scale that we've been given, it states for every 2 centimeters on paper, it's equivalent to 12.5 feet in the real world. Or we could also say 12.5 feet, if we like the decimal version better. We're going to use the table technique and convert each of those given dimensions to centimeters. Remember, 2 centimeters on paper equals 12.5 feet in the real world. Centimeters, that's our X value, and our Y value, well, that's feet. Let's get our conversion rate by placing Y over X. And in this case, it's 12.5 or 12.5 divided by 2. Take a moment and punch that into your calculator. 12.5 divided by 2. You should get a conversion rate of 6.25. Now, since we're going to be converting from feet back to centimeters, we are going to have to divide each given dimension by 6.25. Let's begin. 50 feet, which of course should go in the feet column, divided by 6.25, and 25 feet, as we work backwards, needs to be divided by 6.25. We are moving from the actual real world dimensions to the model dimensions. Pause your video, grab your calculator, and divide 50 by 6.25 and 25 by 6.25. Please pause the video. When you're ready, turn it back on. You should have gotten a length on paper of 8 centimeters and a width of 4 centimeters. Now, let's calculate the perimeter of the model rectangle, and let's calculate the area of that same model rectangle. Remember, if you're taking a perimeter walk, you're going to add 4 centimeters plus 8 plus 4 plus 8. Perimeter, please take down these notes, is 4 plus 8 centimeters plus 4 centimeters plus 8 centimeters. In a moment, you're going to calculate the perimeter. Next, we need to find the area of that rectangle. And again, we're going to use the area formula, base times height. But in this case, we're going to use the model dimensions. 8 centimeters times 4 centimeters. Take a moment and find the area in centimeters squared, or square centimeters. Compare your answers to the correct answers. Now move on to the next page. This concludes page 3